So this session, we are until now we talked about blockchain, many important lectures on blockchain. But if you think about blockchain, without internet it's not working, right? So when we think about the internet society and everything, internet is the key. And when we think about the internet, we need to have the most reliable and fast connection, right? Uninterrupted connection. So from that aspect, we are going to have our next speaker. I would like to invite Dr. Yukari Tsuji, Director of Research and Development, NTT Corporation, to give her presentation on next generation communication technology and trust. Yeah, floor is yours.
Good afternoon, everyone. Hi, I'm Yukari Tsuji from NTT, and I'm very excited to be here in front of you, global young leaders. So today I talk about next generation communication technology and trust. It takes about 30 minutes. This is the agenda of my presentation. I'll talk about the introduction of NTT Group, the definition of communications and trust, then explain about ION, which is a future network concept announced by NTT in 2019. Yep. So before I talk, I'd like to show you the conclusion of my presentation. So I guess that this section is the last lecture section. Is it right? In this camp? Two more. But I guess that you are very tired, and after the lunchtime, so you'd like to sleep. So if you remember this, you can take a nap for 30 minutes. No. Okay, so the conclusion is, I believe, maybe, ION will be necessary to support trusted AI-based world. This is the agenda, and I'd like to start with the introduction of NTT Group. NTT Group has 967 companies with over 300,000 employees for providing ICT services worldwide. And NTT Holding Company has main subsidiaries such as NTT East and West from left side for local exchange, NTT Docomo for mobile, and NTT Data Group for global businesses. And we, NTT R&D, is located in the holding company. We received the research budget from these main subsidiaries and provide our technologies to them, vice versa. And the researchers of NTT Group is about 2,300 researchers. And this shows the research fields of NTT R&D. It expands very widely. And I have the responsibility for the network R&D. But it is necessary to learn about not only network, but also the other fields of research, because the network connects everything, and through the connection, we will produce the new values from those. The next topic is communication and trust. You already discussed about the trust several times, but in this trust model, when the truster trusts trustee, the relationship of trust is established. I think the truster is a very subjective position. He or she trusts under three conditions. Number one, this person has many kinds of experience. So the experience he thinks, okay, it's worth to trust. And the second is this truster check by himself or herself and then think it's okay. And the third, some other person whom the truster said, oh, it's okay. So he believed the person and he thinks, oh, it's worth to trust. On the other hand, the trustee is very objective position. The trustee is necessary to be trusted to show the trustworthiness to the truster. For example, if the trustee is human, gender, age, affiliation, and so on would be the factor of trustworthiness. And if the trustee is AI, the accuracy of the model and transparency and so on would be the trustworthiness. And one more thing, not only the trustee, but also the truster has a possibility to be AI. We need to think about that. The next is, what is communication? Generally speaking, the communication is a system or tools to send the information. But is it enough? I don't think so. Because in this figure, he is uncertain whether she can understand or not what he said. Another meaning of communication is this: to exchange the information and feelings until understanding each other. In this situation, I think we can say communication is done. Here, I'd like to explain about the history of communication technologies very, very briefly. The telephone service was began in 1890 in Japan. The telephone line connects two persons or two places. And while they are talking, the line is dedicated for them, so no congestion is occurred. The internet was started in 1967 as ARPANET in the United States. But it expanded rapidly around 1995 because of Windows 95, which enabled the users to connect to the network very easily. After that, IoT, smartphone, and cloud were appeared. Actually, internet is a great invention because internet can connect everything to the network. Under the situation, everybody follows the rules, meaning if someone sends a massive volume of data, more than expected, the congestion is occurred, and it leads to data loss or data delay. Imagine that if you use some kind of critical use cases, such as remote operation or remote construction, and so on, the data loss or the data delay will be a problem. And the study of AI was started around 1950s. After several decades, it is sweeping to expand all over the world because of generative AI. Currently, it is necessary to connect not only human to human, but also human to AI and AI to AI. When connecting between AI, the requirement for the network will be very hard. So in this slide, I show the requirements for the network. Very roughly speaking, network consists of 3 parts: collecting data, transmitting them, and doing some action. As for data, diversity of data sources is very important. And in the phase of transmission, high capacity and low latency are required for sending the information in high performance. And then in the phase of analysis and actuation, the accuracy of the model and transparency will be required. And also, it has to be sustainable. I'd like to explain about these kind of things in detail. The first one is the diversity of data. In this figure, the proportion of user study samples in the security and privacy field are shown. In this figure, the main part is occupied by Western people's data in green line. On the other hand, the blue line, non-Western people's data, declined from 25% to 20% in these 5 years. As a result, this study result is biased towards Western culture. This is one example, but I guess that there are many cases like this. The second topic is data volume. All industries, such as agriculture, education, and manufacturing industries, are progressing digital transformation, DX, and keep to produce many data. To support their DX, the digital industries, such as cloud and security, infrastructure industries, including data center and communication infrastructure, and semiconductor industries, are collaborating each other vertically. And they are trying to make an ecosystem through them. In this situation, the LLMs and AI are very competitive situation now. This graph shows the training cost of AI model in US dollars versus publication date. GPT-3 with 175 billion parameter, which is released in 2020, costs approximately $3 million US per training. GPT-4 and Gemini Ultra, unveiled in 2023 and later, cost 100 to 135 million US dollars per training. In this way, the size of AI model is increasing larger, and the cost of training cost of AI model is getting higher and higher. This is a problem. And let's think about this from the perspective of sustainability. Even in the case of GPT-3, it consumes a massive volume of energy of 1,300 megawatt-hour per training session. This is almost equivalent to one nuclear power plant generation. Very huge. But in the recent LLMs, such as GPT-4o, requires 50 times more energy comparing this of this. What can we do for that? the massive LLM's power consumption. We believe that it is necessary to realize a distributed processing infrastructure. It includes distributed GPUs and databases and what-bit cooperation. I'll explain about these kind of things later. To conquer this kind of situation, we, NTT, announced the ION 5 years ago. ION is the abbreviation of Innovative Optical and Wireless Network, which is next generation optical network and computing infrastructure, realizing high capacity, high quality, low latency, and low power consumption. This is the point of ION, electronics to photonics. We are using the photonics for transmitting and electronics for data processing so far. But we are trying to use the photonics for data processing. Why we choose the optical technologies? This is the reason why. This graph shows the power consumption of electrical wiring and optical wiring. Electrical wiring consumes a large amount of power in the case of the transmission distance is longer or the operating frequency is higher. On the other hand, optical wiring consumes the minimum volume power in the case of the longer transmission distance or higher operating frequencies. And also, NTT has been innovated many kind of optical devices in this slide shown. The photonics transistor and all optical switch in 2019, and optical logic gate and directly modulated laser in 2020. Through these innovations, we convinced that we'll be able to realize ION. This is a roadmap of ION. There are 4 generations. ION 1.0, we provide the optical connection between end to end. For example, data center to data center. And ION 2.0 provides the board-to-board connection. In ION 3.0, chip to chip. In ION 4.0, die to die, inside the chip. In this way, we reduce the power consumption. And in ION 1.0, the main technology for the ION 1.0 is all photonics network, APN. So I'd like to explain about the APN recent activities. The first one is new service in Japan. We already announced the APN ION 1.0 service in 2023. At that time, the speed was 100 gigabit per sec. This new service, we provide 800 gigabit per sec, which is the world-leading guaranteed bandwidth. And also the availability in the major city in Japan. Of course, we achieved the low power consumption also. And also we connected several global data centers outside of Japan. In the United Kingdom and the United States, we have many kinds of trials there. And they showed the very extreme performance in delay and delay jitter. Delay jitter means the variation range of delay time. So When we say delay jitter is very low, it means the delay time is almost the same always. So low delay and low delay jitter is very useful for the operating some remote work. And we also have the trial in Mumbai, India. We connected 3 data centers. And through our technologies, they can handle the 3 data centers as if one big data center. This is the example of distributed GPU clouds for AI learning. There are 2 data centers. Each one has 4 GPUs. And the distance between them is approximately 40 kilometers. We compared 3 patterns. One is the 8 GPU, one big center. And the second one is a 2 data center connected by legacy internet. And the third one is 2 data centers connected by ION APN. At that time, the legacy internet case takes 29 times for training, AI model training, comparing with one big data center. But in ION APN case, it is only 1.006 time. So we can handle the 2 data centers as if one big data center for AI learning. The next, I'll show about the watt-bit corporation. We'd like to control the workload depend on the supply and demand of renewable energy. For example, we have heavy workload here in Kyushu area, but the power generation is very low because of the rainy, like today. At that time, the workload will be moved to another place in Hokkaido. There is power generation is very high. So in this way, we can improve the usage rate of renewable energy. Next shows the world first international APN connection between Taiwan and Japan. This is last August. They show this APN shows very extreme performance in delay jitter, and very stable communication. And NTT will provide data backup services or replicant services for the industries based in Taiwan and Japan. Another example of ION is teleconcert. Please listen it. Thank you. The players said they didn't feel any distance or any delay. So I heard this concert at the venue of the Shibuya in Tokyo. It was awesome. As I explained already, the APN service was begun in Japan, but it is private line services. So we'd like to expand more wide area and more services for the many use cases. So for this purpose, we'd like to provide on-demand end-to-end direct optical connection for each user. For this purpose, we are developing two kinds of nodes. One is APN-T, which can connect many kinds of devices to all photonics networks. And the other one is the APN-I, which has a function of optical wavelength conversion, meaning the APN-I can exchange the optical path directly and instantly by the operator requirements. In this way, APN-I and T can realize the cost and energy efficiency of APN network. Further reduction of power consumption will be achieved after ION 2.0 and later. So we'd like to continuing our efforts for that. And to foster future trusted air world, I believe two kinds of things are necessary. One is flexible and distributed ICT infrastructure with high performance. It will be ION, I think. And the second one is the diversity of training data for LLMs. In this venue, there are many people who have very various background. And I think this kind of diversity is the most important thing to realize a prosperous society for everyone. This is a conclusion. It's time to wake up. I believe that ION supports trusted air-based world. And we are collaborating with many partners. Especially, ION Global Forum has over 150 members worldwide now. So we are making the use case white papers and technology report. And please check it in the URL. That's all from me. So let's make a sustainable world together. Thank you for listening.
Thank you, Ms. Tsuji, for your nice presentation, and we can see that the future is more exciting.
Thank you.
So I want to open the floor for the questions. So I think many of you have many questions. So raise your hand. Okay, yeah, please. Okay, next to you. You can come here.
Thank you very much for your presentation. I've read about this type of different, we'll call it kind of materials or engineering that some time ago, and it's really interesting. But my major question is it much more expensive than a normal system, or what other drawbacks it has?
Thank you for your question. It's a very nice point. So far, it is a little bit expensive, honestly speaking. But we will expand the area of services, and the number of users are increasing. So after that, the cost will be reduced.
Sorry, a follow-up
Yeah,
question
okay.
very briefly. So would you say it's more a problem of a scalability and that it's a recent technology, right? Rather than
Right,
materials.
right.
Okay, thank you very much.
Thank you so much.
Okay, next.
Thank you for such a lovely presentation. If you can go back to slide 26, please.
Which one?
Slide 26, yeah, just before this one.
This one?
One more, Ben.
One more?
Yes.
So can you please explain this a bit again? Because it seems like you essentially clustered 4 GPUs together, right? So you had 4 GPUs in Mitaka and, sorry for the pronunciation, 4 GPUs in Akibara, right? So have you only looked at clusters of GPUs and not CPUs? And also, have you tried scaling it up in terms of like CPUs and GPUs together?
And
Yeah, sorry, might be a bit
no.
technical.
Thank you. Thank you for your question. And sorry, but I'm not sure the exactly condition of this experience. But the GPU is 4 GPUs are in one data center. Is this okay for you?
Yes.
And your point is CPU.
Yes, so I can see that you have clustered the GPUs, right? So I was wondering if you did the same for CPUs or not, because GPUs provide the parallelizable ability, but the CPUs also provide like other technical capacities. So I was wondering if you did that for the CPUs as well, like scaling it up.
Sorry, but I don't have the in detail about that. Maybe the CPU is also considerable, but sorry about that.
Yeah, no worries.
Yeah.
Also a follow-up question. Did you only do this for 2 centers? Have you like scaled it up for multiple centers?
Yeah. Currently, we are using the Mumbai use cases, so we expand the number of the data centers now.
Okay, so in between, like inside the country itself, but not between countries or anything like that?
Inside countries.
Okay, cool. Thank you.
Thank you.
Okay, please.
Can I have one
Next.
question?
Yeah.
Yes.
So, how much bandwidth are you aiming to achieve in the long run? So I saw now it's 800 Gbps, but what is your higher goal to achieve? Like, what is the maximum speed what you are trying to achieve?
This one or
Yes.
the connection between data centers?
Yes, for example. Because that may change our assumption.
I could help you. This is DWDM. Means
Yes.
current technology is 800 gig.
Yes.
Though already 2 tera, already one. Because it's just a transparent glass, WDM, so you don't need to care about that. For the silicon part.
Thank you, Esaki sensei. Very helpful.
Yeah, thank you so much.
Okay.
Thank you.
So, is there any other question? Okay.
Thank you. My background is AI and IoT. So yes, very interesting of your research. And my question is, do you know that what do you think that why is AI is important when we integrate with our IoT and internet system? Like because like that someone need the data, right? So we trust the data, and we collect it for integrate with the AI, like the LLM model, something to know about our system, and then okay, yes, my question is like, I think what you get my question, right? Like, Sorry.
It's okay.
My question is, what do you think? Why is AI is important in for integrating like internet or sustainable energy something?
Well, I'm not sure what I can catch your point or not, but for AI learning or some kind of things like that, the stable communication network is very important because the transaction between AI is very strictly. So we human can wait for the data is sent, but AI can't wait that. So the reason why I believe the very high performance network will be necessary for AI system. Is it right for your question?
Yeah. Thank you so much.
Thank you so much.
Thank you. I have one question.
Yes.
Sorry about that. So actually, I feel that in terms of power consumption and stability, so ion is the future, I feel. But what is the, you think that other competition, that other technology, because you know that EVs like Toyota's hydrogen car and EV, which one will be win? There was a competition like that. So similarly for this kind of technology, what is the competition there? So I want to know that.
Okay. For example, I compared the legacy internet and ION APN, but I think these kinds of technologies are not the competitive situation. I think maybe we use them by the combination of the technology, as you say. So we will use the technologies, light technologies.
Okay, I understand.
Is this okay for you?
Yes, I understand.
Yeah.
Thank you so much.
Thank you.
Once again, big hand for Dr. Tsuji.
Thank you so much.
Before that, I want to share one more information. We are actually going to have a special gift from NTT, so from her. So another big hand for you. Thank you.
Yes.
So everyone, when you are going out for the excursion, you will get one from the entrance. Okay?
I'd like to explain very briefly. This is a very small gift for you, and we, NTT, hired the handicapped persons. So they make them by hand. So please send this to your home for the Japanese souvenir. Thank you.
Thank you so much.